Hello students, welcome to my PKM classes. Today we study about the induction. What is induction? Induction is a process. Induction is a principle to solve the questions. So it is a proof, it is a method of proof to solve a question. There are different methods, DAG methods, contrapositive method, method of syllogism. So induction is a method or it's a process to solve the problems. Now, the law of induction says that what is theory of induction or law of induction? Law states that let Pn denote the sequence of statements. The sequence of statements. Let Pn denote the sequence of statements. Next, we verify P1 is true for n is equal to 1. Next, let us assume that Pm is true. Pm is true. If Pm is true for n is equal to m, if Pm is true implies Pm plus 1 is true, then we say by principle of induction Pn is true. Now in the induction we take Pn, that is the sequence of statements. First of all we have to verify P1 is true for n is equal to 2, P2 is true for n is equal to 2. Then take assumption that Pm is true for n is equal to m. If Pm is true implies Pm plus 1 is true, then we say by principle of induction Pn is true. Let an example. Suppose question is asked like this: prove by method of induction. 1 plus 2 plus 3 plus ... plus n is equal to n whole into n plus 1 by 2. Now we prove this by method of induction. When we prove by method of induction, first to take this is Pn. So Pn, let Pn denoted the statement. Let Pn denoted the statement, that is sequence of statements 1 plus 2 plus 3 plus ... plus n is equal to n whole into n plus 1 by 2. Let this is equal to Pn. So let us assume that the given statement is Pn. Next we verify that when n is equal to 1, then LHS is equal to 1, RHS is equal to 1 whole into 1 plus 1 by 2, 2 by 2 is equal to 1. Now we find LHS is equal to RHS. As LHS is equal to RHS, when n is equal to 1, then the given statement is true, or that is P1 is true for n is equal to 1. That means the given statement is valid. The given statement is true when n is equal to 1. Next, suppose n is equal to 2. Let n is equal to 2 or when n is equal to 2. Now we find left hand side is equal to 1 plus 2. When n is equal to, this is the general term. When put n is equal to 2, left hand side is equal to 1 plus 2, that is equal to 3. And RHS is equal to 2 whole into 2 plus 1 by 2, that is equal to 3. So LHS is equal to RHS. This shows that P2 is true for n is equal to 2. Now see, P1 is true for n is equal to 1. P2 is true for n is equal to 2. Let us assume that Pm is true for n is equal to m. This is the assumption step, or step 3. Let Pm is true for n is equal to m. Let Pm is true for n is equal to m. That means the given statement is valid. The given statement is true for n is equal to m. When n is equal to m, the given statement is true. This is our assumption. We let this that Pm is true for n is equal to m means the given statement is valid when n is equal to m. So up to mth term, sum is valid, sum is true, or that means, or that is 1 plus 2 plus 3 plus dot dot plus m is equal to m whole into m plus 1 by 2. We have to show that Pm plus 1 is true whenever Pm is true. Now in step 4, we find Pm plus 1. Pm plus 1 is equal to 1 plus 2 plus 3 plus dot dot m plus 1, or that is equal to 1 plus 2 plus 3 plus dot dot plus m plus 1. So now this is the m plus 1 term and this is mth term. Up to 1 to m term, we know the sum is m whole into m plus 1 by 2. So in place of 1 to m, we write m whole into m plus 1 by 2 plus m plus 1. Now taken m plus 1 is a factor, or that is equal to m by 2 plus 1, or that is equal to m plus 1 whole into m plus 2 by 2. Now we find when n is equal to m plus 1, that is equal to n into n plus 1 by 2. N into n plus 1 by 2. So the given statement is true when n is equal to m plus 1. As when Pm is true, we have Pm plus 1 is true. As Pm is true, so Pm plus 1 is true. As Pm is true, when Pm is true, we find Pm plus 1 is true. So in principle of induction, Pn is true. Now we observe. Number 1, P1, P2, P3 dot dot are true. Number 2, truth of Pm implies truth of Pm plus 1 is true. Hence, by principle of mathematical induction, Pn is true for all n. Now we find P1, P2, P3 dot dot are true. Whenever Pm is true, this implies Pm plus 1 is true. So Pm true implies Pm plus 1 is true. Then by principle of induction, Pn is true for all n, or that is 1 plus 2 plus 3 dot dot n is equal to n whole into n plus 1 by 2. Now this is we prove to sum of 1 to n terms is equal to n plus 1 by 2 by argument. Argument means we take the entire statement is Pn. Pn denotes the sequence of statements. First of all, we verify when n is equal to 1, left hand side is right hand side. Next, we take assumption that Pm is true. When Pm is true, if this implies Pm plus 1 is true, then the method of induction Pn is true. Let us see another example. Now, question is given that by method of induction prove that 1 square plus 2 square plus 3 square plus dot dot plus n square is equal to n whole into n plus 1 whole into 2n plus 1 by 6. Now prove this question by method of induction. It is given that by method of induction, so that 1 square plus 2 square plus 3 square plus dot dot n square is equal to n whole into n plus 1 whole into 2n plus 1 6. First, we take the sequence of statement is Pn. Let the given statement is Pn. That is Pn denote the sequence of statements. Let now write let the given statement is Pn. That is Pn is equivalent to 1 square plus 2 square plus 3 square plus dot dot n square. N whole into n plus 1 whole into 12 plus 1 by 6. Next, in step 1, we verify when n is equal to 1. When n is equal to 1, then LHS is equivalent to 1 square. That is 1. RHS is equivalent to 1 whole into 1 plus 1 whole into 2 plus 1 by 6. That is equal to 2 into 3, 6 by 6 is equal to 1. Now we find LHS is equal to RHS. When n is equal to 1, left hand side is equivalent to right hand side. That implies P1 is true for n is equal to 1. Now when n is equal to 1, left hand side is equivalent to right hand side. This means that the given statement is right. The given statement is true for n is equal to 1. Next, we take the assumption step. Let the given statement is true for n is equal to m. The sum of m terms, when n is equal to m, the sum of m statements is true. That means, let in this step 2, let Pm is true. Let Pm is true for n is equal to m, or that is 1 square plus 2 square plus 3 square plus dot dot m square m whole into m plus 1 whole into 2m plus 1 by 6. This is our assumptions, and we assume that let Pm is true for n is equal to m. Now we have to show that Pm plus 1 is true. Now we find what is Pm plus 1. Now Pm plus 1 is equal to 1 square plus 2 square plus 3 square plus dot dot m plus 1 whole square. When n is equal to 1, in general term we input n is equal to 1, then we find P1 is equal to 1 square. When n is equal to 2, left hand side is equal to sum of 1 square plus 2 square. When n is equal to 3, 1 square plus 2 square plus 3 square. This is the general term. When n is equal to m plus 1, the m plus of the term is m plus 1 whole square. When n is equal to m term is m square, or that is 1 square plus 2 square plus 3 square plus dot dot m square plus m plus 1 whole square. Now sum of 1 square plus 2 square plus 3 square dot dot m square is equal to m whole into m plus 1 whole into 2m plus 1 by 6 plus m plus 1 whole square. Take LCM is 6, that is equal to m whole into m plus 1 whole into 2m plus 1 plus 6 whole into m plus 1 whole square by 6. By taking m plus 1 is a factor, By taking m plus 1 is a factor, now we observe that is m plus 1 into m plus 1 whole into 2m square plus m. When take m plus 1 common, that is 6m plus 6 divided by 6. Now take m plus 1 as a factor. The remaining part is 2m square plus m. And m plus 1 is a factor. The remaining part is 6 whole into m plus 1, that is 6m plus 6. Or that is equal to m plus 1 whole into 2m square plus 7m plus 6 by 6. And that is equal to m plus 1 whole into 2m square plus 4m plus 3m plus 6. We take a factor. Product is 12, sum is 7. Now we write 4m plus 3m, that is equal to m plus 1, 2m is a factor, m plus 2, 3 is a factor, m plus 2 by 6. And that is equal to, right, and that is equal to, take m plus 2 is a factor, m plus 1, m plus 2, 2m plus 3 by 6. Now this is equal to pm plus 1. When m is equal to m plus 1, you write n whole into n plus 1 whole into 2 whole into n plus 1 plus 1. Now when it is in the form of n whole into n plus 1 to n plus 1 by 6. So when n is equal to n plus 1, it is in the also form n whole into n plus 1 into n plus 1 by 6. This implies Pm plus 1 is true. Pm plus 1 is true. Now Pm plus 1 is true whenever Pm is true. As Pm plus 1 is true whenever Pm is true, then by method of induction Pn is true. Now right, we have what we find. Now we have, or we observe that number 1, P1, P2, P3 dot are true. Number 2, truth of Pm implies truth of Pm plus 1 is true. Hence the principle of induction Pn is true by method of induction. So by method of induction or by PMI, principle of mathematical induction, Pn is true. So by principle of mathematical induction, Pn is true for all n. That means 1 square plus 2 square plus 3 square plus dot dot n square is equal to n whole into n plus 1 by 2. So when we prove a question by method of induction, first we take Pn as the sequence of statements. Next we verify the statement is true for n is equal to 1, n is equal to 2, like this. Then we take assumption step when the statement is true for n is equal to m. N is equal to m. Next, we have to show that Pm plus 1 is true whenever Pm is true. Or that is most important factor by method of induction. If Pm plus 1 is true, whenever Pm is true, or that is Pm is true, implies Pm plus 1 is true. Then by induction, Pn is true. In this way, we solve the problems of induction. Now, we know what is induction, how it is solved. Thanks to all.